Hello everybody, Sorbeaten here and welcome back to another Passable video. In this video, we will be tackling some linear programming questions. So let's head straight into the first one. So the question says, the diagram below shows the graphs of three lines as shaded region defined by three inequalities associated with these lines. The inequality associated with the line 3x is equal to x is 3x is greater than or equal to x. So this question says, state the other two inequalities which define the shaded region. So in this question, we are already given the inequality for this line here. So let me use a different color. We are already given inequality for this line here. Next, they want the inequality for this line and this one here. So let me do this one. So what we can do in order to find the inequality for this line, what we can do, we can substitute values into the shaded part, and then we will decide which direction the inequality sign will go, whether it be more than or less than. So what we can do, we can choose a point inside the shaded part. So let's choose this point here. So we see this point here would be, we go 10 across and we go 10 up. So if we substitute that into here, we'll have x plus y is equal to 40. So 10 plus 10 would be 20, and 20 is obviously less than 40. So we see this inequality line that is shaded here. It's not broken. When it's broken, then is when we'll just put the less than or more than. So because it's not broken, we'll have to add in the equal to part at the bottom. So the inequality would be x plus y would be less than or equal to 40. And to double check this, what we can do, we can choose another point. So let's choose the point, let's choose this point here. So we see the coordinates for that point would be, here would be 15. So it's 15, 20. Let's go, x would be 15 plus 20, would be less than or equal to 40. So 15 plus 20 would be 35, is less than or equal to 40. So that is true. So our inequality would be x plus y is less than or equal to 40, that is 1. So I'll write that here, x plus y is less than or equal to 40. And the next one would be easier. So here we have x is equal to 6. So we see all the values across here will obviously be greater than or equal to 6. So you can say x is greater than or equal to 6, and that would be the other inequality. So this would be 1, and this would be the other one. As easy as that. So the next set of questions says, the function p is equal to 4x plus 3y satisfies the solution set represented by the closed triangular region. First one, identify the three pairs of x and y values for which p has a maximum or a minimum value. So let me work out 2 here. So to get those pairs of points, let me erase what we have. To get those pairs of points, we'll just take the vertices of the triangle. The vertices will be the intersection of all of the lines. So let me use another color so that I can see this clearly. So it's the intersection of all of the lines. Those coordinates would give me the points that will give P either maximum or minimum. So let's take this one here. So this point here is nice and easy. So it's 30. We go 30 across and we go 10 up. So that is 30, 10. And for this one here, we see we go, so here, so we see here would be 5. So it means here is 6. So we go 6 across, and then we see we go 1, 2 up. All right, so 1, 2. So 6, 2. And then here would be, so we see we go the same 6 across. And then we see we go up 31, 32, 33, 34. So 6, 34. So the points would be, one would be 6, 34. That one would be 6, 2. And then 30, 10. And those would give me, those are the three pairs of x and y values for which p has a maximum or a minimum value. So let me change back my color. So let's find for 3 now. Which pair of x and y values makes p a maximum? Justify your answer. So what we need to do, we need to substitute each one of these coordinates into the function, and whichever one gives us the highest value for P, that would give us that will be the pairs of coordinates that makes P a maximum. And that will give us the pair of coordinates that makes P a maximum. So let's substitute this first one. So we see the function is P is equal to 4x plus 3y. So P is equal to 4x plus 3y. So let's see. So P would be equal to, so we're using this one first of all. So it's, instead of 4, we'll have 4 multiplied by, instead of x, we'll have 6. So 4 multiplied by 6 plus 3 multiplied by y, which is 34. So P would be equal to 4 times 6 is 24 plus 3 times 34 would give us 102. Hence P would be equal to 126. So P is equal to 126. And next one we'll have P would be equal to 4. Instead of x, we'll have 6 plus 3 times 2. So 4 times 6 would be 24 plus 3 times 2 would be 6. So P is equal to 30. So P is equal to 30 here. And last but not least, we see P would be equal to, so let's use the last one now. So 4 times 30 plus 3 times y, which is 10. So 4 times 30 is 120 plus 3 times 10 is 30. Hence P would be equal to 120 plus 30 is 150. So P is equal to 150. So you can say, therefore, P makes a maximum at 30, 10. And our justification will be there's substitution here. So P makes a maximum at 30, 10. And with that, this has brought me to the end of this video in which I tackled some linear programming questions. And I trust that you have a good understanding, and I'll see you in the next video in which I'll be tackling some more. Until then, take care and keep practicing. Exam is coming up sharply.